So we've been talking about mass for elements. Remember, we said that the atomic mass is the mass of one atom. The molar mass is the mass in grams of 1 mole of an element or a compound. We can also sometimes use the word molecular weight. Okay? So you'll hear me use those two terms interchangeably, molar mass and molecular weight. Okay? So here's the way we calculate molar mass. Here we've got a compound called juglone. It's a dye, and it has a formula of C10H6O3. So I have to break up my compound into all of the elements that make it up. I've got 10 carbons, I've got 6 hydrogens, I've got 3 oxygens. I'm going to multiply those values by the number from the periodic table. And I'm going to round this a little bit. So carbon is 12.011. I'm going to go ahead and make this 12. Hydrogen is 1.008. I'm going to go ahead and make that 1. And oxygen is 15.999. I'm going to go ahead and make that 16. Okay? 10 times 12 is 120. 6 times 1 is 6. 3 times 16 is 48. I'm going to add all of those numbers up, and I get 174. This is the molar mass, so it's grams of C10H6O3. So 174 grams of C10H6O3 is equal to 1 mole of C10H6O3. It's the exact same thing we did with elements, only this time we have a compound. Okay? So here's how we use this information. Okay? I'm told that I have 1.56 times 10 to the negative 2 grams of juglone, which we said was C10H6O3. I'm told I want to find out how many moles I have. Well, just like I did before, I need to make grams go away. So grams go on the bottom. I need to change to moles. So moles go on top. Now, just like before, grams we find on the periodic table, but for the compound, it's the entire thing. It's what we just calculated, 174 grams. And the number from the periodic table is equal to 1 mole. Numbers on top we multiply. 1.56 times 10 to the negative 2 times 1 stays the same. Numbers on bottom we divide. Divided by 174. I get 8.9655. I started with 3 significant figures. 1, 2, 3. I keep 3. So it becomes 8.97 because the 5 rounds it up. I should also see 10 to the negative 5th in my calculator. And this is moles. I can either write juglone or C10H6O3. Okay? So take a second and calculate the molar mass of calcium carbonate. Calcium, carbon, and oxygen. Okay? Once you have the molar mass of calcium carbonate, I want you to determine if you have 4.86 moles, what is the mass? So calcium, we have 1. Carbon, we have 1. Oxygen, we have 3. If I look on the periodic table, calcium weighs 40. Carbon weighs 12. Oxygen weighs 16. If I add those 3 numbers up, I get 100 grams for calcium carbonate. I'm starting this time with moles, so I need moles to go away. I'm changing to grams. Well, there's 1 mole of calcium carbonate for every 100 grams. 4.86 times 100, I get 486 grams calcium carbonate. So all of these calculations are exactly the same as we did with elements. The only difference is before I can do my calculations, I need to add up all of my elements in the compound and make sure I know how many of each I have. Okay? So the next thing we're going to talk about is called percent composition. So there are 2 ways of describing how a compound is made up. One is in terms of numbers. So C6H12O22, that's numbers. The other is in terms of percentages. Okay? We can talk about mass percent, which is also sometimes called weight percent. And what we're doing is we're comparing the mass of each element in the compound to the total molar mass. So here's the way this works. I've got my compound, this time it's carbone, C10H14O. Okay? I want to compute the mass percent of each element. So I've got C, H, and O. Just like before, 10 C's, 14 H's, 1 O. I look on the periodic table. Carbon weighs 12. Hydrogen weighs 1. Oxygen weighs 16. And I add all these up, 120, 134, 144, 150. So this is my total mass. I want to find the percentage of each element. So all I do is take the amount of each element, divide by the total, and because it's a percent, times 100. So 120 divided by 150 times 100, I get 80% carbon by mass in that element, or in that compound. 14 divided by 150 times 100, I get 9.3% hydrogen by mass in that compound. 16 divided by 150, because remember that's my total, times 100 equals 10.7% oxygen by mass. Okay? So all we're doing is we're finding out how much of each we have compared to the total. So take a second and solve example 7. Our compound in example 7 is penicillin. You're going to find the mass percent of each element in C14H20N2SO4.